Hello everyone. Today we're going to look at the last transformation that we need to see for quadratics before we can put all of the transformations together into one group of transformations. Near the beginning of the unit, I mentioned that there were two different ways of looking at quadratics. One of them is called the vertex form, and one of them is called the factored form. This, just to remind you, this is the equation of the vertex form of a parabola. Now, we'll talk about what that means later, but for right now, we've been looking at all of the different letters to see what kinds of transformations they do to our regular parabola. So what do we know so far? We know that the k value here, we know that the k value here causes the parabola to move up or down. And that's based on whether the number is positive or whether the number is negative. We've also seen this a value here now. And this a value will control multiple things. It'll control whether the parabola has been stretched. Now these are vertical stretches, okay, so stretching this way. Or compressed. And that's based on whether or not the number is greater than 1, or if the number is between 0 and 1. Which I wrote like this once, okay? But greater than 1 will give us a stretch. If it's between 0 and 1, like 0.5, 0.75, it'll be a compression. Because these are stretches and compressions vertically, you've got to think of it like going up and being stretched upwards or squished downwards, okay? And we know that when it's stretched upwards, it's narrower. And if it's compressed downwards, it's wider. We also know that if A is negative, it's flipped upside down. So we talked about how you've got to look at the a value as two different things. If it's a negative number, leave the negative off to the side, just look at the number itself. If that number matches one of these two things, then it's going to be either stretched or compressed. Then look at it if it's negative. If a is negative, it's what we call a reflection, or flipped upside down. Okay, so we know those two letters do something. Now, what do the y and x do? A lot of students will ask me that question. What do the y and x do? Well, the y and x are just there because everything that we're going to be plotting on a y and x axis needs to have y and x in the equation. The y and x just represent all of the different coordinates. So usually what you'll do is you'll substitute a value in for x and then calculate what the answer is for y. Okay, so basically the y and x are there just to link it to the graph. They always have to be in an equation if that equation can be graphed on a y and x graph. So the y and x don't technically participate in the transformations, but they need to be there so that we can actually graph the relationship. Okay, so we're not really going to talk about the y and x as part of the transformations, but we are going to talk about the last letter, which is h. Now, the way I think of h, you can see the word horizontal has the letter h in it. It's the only letter that kind of matches what it actually does. Now I'm going to warn you, unfortunately, h is one of the transformations that students get wrong all the time for one specific reason. We'll see why in a second. But that's the only thing we're going to be focusing on to start. Okay, so we're just going to focus on this part of the equation today. We're going to say that k is equal to 0 and a is equal to 1 for now. And then we're going to see how does the h value change the position of the parabola. So the fact that it's related to horizontal is probably giving you some hints, but I'd like to actually show it to you with Desmos because it'll probably be a lot clearer if you see it that way. So here is Desmos calculator online. We're we're going to graph our y is equal to x to the power of 2 graph. And that is our regular parabola. So if I ask you, before I type it in, what would happen if I wrote y is equal to x minus 2 squared? Actually, let's do x minus 3 squared so that the square and the 3 are different numbers. Okay, so I want to do y is equal to x minus 3 squared. So I'm actually going to just turn this graph off for now. Put my brackets around there. Having trouble with my keyboard. There we go. So which way is that parabola going to move? So I have already kind of given you a hint when I say the word horizontal, but which way is it going to move? Is it going to move right or is it going to move left? So here's the problem. So here's the problem. The problem is that most students will tell me that it's going to move left. Okay? And unfortunately, the parabola will not move left. The parabola is actually going to move right. So if I turn it on here, you'll see that the blue parabola has moved right. Now to explain that, and I will try to explain it in a few minutes, but it's actually not easy for students to understand why that happens. So what I'd like you to think about is what number would you replace x by to make the bracket equal to 0? And that number would be a 3. Now that's a more mathematical way of figuring it out, and it would be a positive 3, not a negative 3, but it's still, you don't understand why that's happening. So here's what I tell my students. Whatever is inside the bracket, you've got to get used to the fact that that's lying to you. It's telling you the opposite of what's going to happen. So if it's inside the bracket and it's a minus sign, it actually means move right by 3. And just to prove that, if I do y is equal to x plus 4 or 5 to the power of 2, that graph has moved left, sorry, I almost messed up there, left by 5, okay? So you'll notice that the vertex, which is at 0, 0, is what's moving, okay? So this is starting to hopefully get you to understand why we call this form of the equation vertex form. It's, if we know where the vertex has gone, we have a very good idea as to what the position of the parabola is going to be, not its full shape, but at least where it's starting from. And then we can figure out with the a value what its overall shape is going to be. So if you look at the value inside of the bracket here, let's just look at x minus 3. If we go to the parabola x minus 3 squared, look at the coordinate of the vertex. The coordinate of the vertex has the same number that's inside the bracket here, but again, the opposite sign, right? So it's a negative 3 in the bracket, but it's a positive 3 on the x-axis. If it's a plus 5 in the bracket for this one, look at the coordinate of the vertex, it's a minus 5. So just to reinforce that idea, if I do another one, y is equal to bracket x, let's say plus 6 to the power of 2. Okay, so look at the coordinate of that vertex. It's negative 6, 0, where it's a positive 6 inside the bracket. So just to push you a little bit further today than what I was going to do, what if we combined the h transformation, which is the number inside the bracket here, with the k transformation? What if I added a number like 4 to the end of that equation? What would happen to that parabola? Well, we know that the parabola moves up and down based on the k value. This will help me reinforce the idea of what happens inside the bracket versus what happens outside the bracket. If I put a plus 4 on that parabola's equation, look at what happened to the parabola. it moved up by 4. Look at the coordinates of the vertex. And again, I'm reinforcing the idea of what happens inside the bracket versus what happens outside the bracket. Inside the bracket, you've got a -3, but it's a +3 on the vertex. You have a +4, and it's also a +4 on the vertex. So the x value is the opposite sign of what was inside the bracket, and the k value is the same sign as the coordinate for the y value of the parabola's vertex. So again, this is called vertex form because if you know the two numbers inside the bracket and outside the bracket, you can actually tell me the exact coordinate of the vertex. And we're going to see that a little bit more later on, but I just wanted to introduce that idea since we've already seen the K transformations. Okay? So for today, the main thing right now is that if you have a number inside the bracket subtracting or adding, it's going to move the vertex of our original parabola, which is 0, 0, in the opposite direction of the sign inside the bracket by the number that's inside the bracket. So if it's a -3, it's moving +3. And I know I'm harping on that idea, folks, but it is one of the most difficult things for students to understand. Sorry, not understand, but to actually remember. So let's go back to our smartboard here. And let's look at some examples together. So let's say I asked you, which way does each quadratic equation move the parabola? And I ask you, following this equation, so answer the question, which way does each quadratic equation move the parabola? And here's our first example. So as soon as you see a plus in here, I want you to say left, and then usually by how much? By 4. If I ask you to do the same thing with this equation, as soon as you see a minus here, you have to remember that it's the opposite of what you expect, so it's right by 3. Okay? And if you can remember that, you won't have any problems with this, but I know from experience that students have a very hard time remembering that, and frankly, I've made mistakes still to this day, because when you see a plus, we usually think moving to the right, and when we see a minus, we usually see moving to the left. Now, let me try to explain why that happens, and like I said, this is not an easy explanation, okay? So if you don't understand this, it's not a big deal, but I'm going to try to explain it. Now, I wish I could draw a parabola very well on here, but I always seem to struggle. Let's see what I can do. Okay, that's not so bad. So I want you to take a look at a point on this parabola here. So let's say that coordinate, and we know that the regular parabola, if x is equal to 2, that we do y is equal to 2 squared, which would be y is equal to x squared, so y is equal to 2 squared, so 2 squared would be 4, so the height of this point would be 4. Okay? So what I want you to do is I want you to put yourself in the mind of a mathematician. We have to move this parabola over. So let's say we moved it over to sorry, let me use another color here, to point -3. Okay? Now where did this 4 height go? That 4 height is here. All right? What is the x value underneath that, the new x value underneath that 4 height? And I'm actually going to use purple to show this. Okay, so we still have the exact same height of 4, but what is the new x value right underneath that height? Well, remember that our original one was 2 away from our vertex. Well, what's 2 away from negative 3? On the right of negative 3. So 2 away from negative 3 is negative 1. I'm sorry about the scale here, but it's as good as I can get it, okay? But that distance is 2 away, so we're at negative 1. I still need to have a height of 4 at negative 1. So let's look at this with equations, okay? For our original parabola, we had y is equal to x squared. We subbed in 2 for x. And what y value did we get? We got 4, okay? For this red parabola that I've moved over by 3 to the left, I know that if I sub in negative 1, I need to get 4 as my answer. So how do you do that? Well, the x value is still in this position right here, okay? So I'm just going to put negative 1 right there. Now, if I do negative 1 squared, I don't get 4. I need to get 4, okay? So because 2 gave me 4 originally, I need to get this to equal 2 again. So what am I going to do to make it equal to 2? Well, negative 1 plus what equals 2? Negative 1 plus 3 equals 2. This is my x value. I add 3 to the x value so that negative 1 plus 3 gives me 2, and 2 squared gives me 4, which is what gives me that point. And if you look at the equation that we just got, it would be x plus 3 squared. And that's how mathematicians figured out that you need to put a plus 3 in the bracket in order to move the parabola left. Okay? Technically, the plus 3 isn't moving the parabola. It's the x value that's moving the parabola. Okay? But we want to get the x value to give us back our 0, which is our vertex point 0, 0. Okay? So it's quite complicated to try to understand. If you did, great. If you didn't, just remember that it's always the opposite of what's inside the bracket. So what if I asked you to graph without technology y is equal to x minus 5 squared? How would you graph that? So yes, it just moves to the right by 5, but we always, and the reason I'm showing this, folks, is because when we get into multiple transformations, it can get a little confusing, and it's always a good idea to go back to our table of values and set up the way we've been doing before, an x and y table, and transform the points to see how the points transform. Okay, so we're going to create a new table of values from our old table of values. Now, when you're doing an x transformation, as soon as you see there's an x transformation, and this is brand new, so it's going to look a little weird at first, but you'll understand in a minute. You want to leave yourself some room under the x column, because you're transforming the x values, which means we're going to be doing some math to those x values. So I'm actually going to do negative 2, negative 1, 0, 1, 2. So we did this for our vertical transformations as well. We just set up a whole bunch of x values. It's always nice to use some negatives, a 0, and some positives. So I'm going from negative 2 to 2. I'm going to leave some room here to do my transformation. Now, what are my regular y values? My regular y values are squaring the x values. So it's 4, 1, 0, 1, 4. If you don't remember what I'm talking about, I'm just using the regular equation y is equal to x squared for now. We're going to take our regular parabola, y equals x squared, and transform it. Okay? So how is it being transformed? Well, we've got this negative 5 here, right? That's not affecting the y values this time. that's affecting the x values because we're moving the parabola left and right, which are our x values that are changing. So what am I going to do to each x value? Well, this is where you have to remember that it does the opposite of what you think. We're going to add 5 to each one of our x values. Okay, so let's write our new table with our new coordinates. Sorry about that. So what is our new table going to be? So our new x values are going to be -2 plus 5, which is 3, -1 plus 5, which is 4, 0 plus 5, which is 5, and this is our vertex, right? 0, 0 was our original vertex. Now we're moving our vertex to 5 and our y value. So that's where you see very clearly, I mean, you can see it with these ones as well, but this is where you see very clearly that the vertex has moved to the right by 5. 1 plus 5 is 6, 2 plus 5 is 7. So again, all of our points have moved to the right by 5. And then because there's no y transformation, I'm just going to repeat all the y values. And then you're ready to graph this parabola. If you plot all those points, and I'm going to do this really fast here, if you plot all those points, so 3, 4, I'm actually going to put the parabola's vertex in here first so that I kind of have an idea. So 5, 0 is that point, okay? 3, 4 would be like, let's say here, 4, 1 would be here, 5, 0, 6, 1, 7, 4, and I'm not going to draw the curve because it's really hard to draw with my smartboard, but that is your parabola right there. Okay, so let's do another one quickly. What if I asked you to graph y is equal to x plus 6 squared? Okay, so you would start off as before. I'm actually going to draw both tables of values right away. So x and y. I have an x transformation, so I'm going to leave some room next to the x. I'm going to write in all of my original x values that I usually use for parabolas. Do the same thing for the y value. And then I'm going to do my transformation. So in this case, it's plus 6, so it's doing the opposite because it's in a bracket. So I'm going to subtract 6 from all of the y values. So let's put our x and y values here. So -2 minus 6 is -8. -1 minus 6 is -7. 0 minus 6 is -6. And once again, that is my vertex right there. Okay, matching up with the 0, 0. 1 minus 6 is -5. 2 minus 6 is -4. And all of my original points have moved left by 6. My y values don't change in this case. And now I have the ability to plot my parabola. I should have flipped that one around here. Let me redo that, sorry. The x-axis usually points in this direction. However, notice that I'm leaving a lot more room on this side, and that's because I've got to go all the way up to -8. So looking at your table kind of tells you where your parabola is going to show up. Okay, we call these quadrants, by the way. So this is the first quadrant, and this is the second quadrant. It's weird that we're going backwards, I know, but that's the way it's counted. So anyway, it's going to be over here. So if I plot those points, So negative 8, let's say, is way over here. Negative 8 and 4. Negative 7 and 1. Negative 6 and 0. Negative 5 and 1. Negative 4. Oh, wait a second, I made a mistake there. I made a mistake here too. That's supposed to be a 4, and that's supposed to be a 4. So some of you may have noticed that. Negative 4 and 4 would be here. And there is my parabola that is moved to the left by 6. Okay, so don't get confused about that 8. This is negative 6 right here. So my vertex has moved to the left by 6, which means all of my points have moved to the left by 6. So what we can also do now to move us a little bit ahead is what happens if I throw the a value in there as well. Okay, so combining two transformations. Eventually we're going to do all three. Okay, but for today we're just going to end with this. So what if I asked you describe the transformations okay, so let's do this one. So let's say we went y is equal to negative 2 times x plus 4 to the power of 2. So the first thing you would notice is this is a quadratic because it's a power of 2. And we have our a value here, and we have our h value here. So you have multiple things to discuss here. So what does the a value do? The a value, first of all, is negative. So it's going to reflect upside down. Okay, so you can also say vertical reflection, but I find upside down helps students really visualize what's going on. It's also going to do what because of the 2. Now, if we go back to one of our previous slides, right at the beginning, I said that if a is greater than 1, it becomes narrower, and if it's between 0 and 1, it becomes wider. So, and this is just the number, not the negative sign, just the number. So is 2 greater than 1, or is 2 between 0 and 1? Well, because 2 is greater than 1, it's going to make it stretched. So that's going to be narrower than a regular parabola. And then what does the h value do? The h value is plus 4. And that does the opposite of what we think. So it's moving the parabola left by 4. And what's nice about this is, what if I just asked you to sketch this without a table of values? Okay, well, you should now be able to tell me that the parabola is going to have a vertex here at negative 4 and is going to be narrower, which I'm having trouble drawing here, sorry, but it's going to be narrower than a regular parabola. Let me try to exaggerate that a little bit. So I'm just going to exaggerate it so you can see that I'm drawing it narrower, okay? Where the regular parabola would be a little bit more wide like that. And it's upside down. So my final one would look like that. So this would be the transformation of moving it to the left, and this would be the transformation of both moving it to the left and flipping it upside down. And if we used our table of values, this would be a lot more accurate. And that's what I'm going to show you as the next example. I think I said this one would be the last one, but I'm going to do one more, okay? So how would you use the table of values? So graph with a table. Let's do y is equal to 3x plus, or let's do minus 6. I think we did a 6 before. Let's do minus 2 squared. Okay? So here's what we're going to be focusing on when we do all of our transformations is the first thing I want you to do is identify which one are y transformations and which one are x transformations. Okay, so we know that A affects all of the y values, and we know that H affects all of the x values. All right, so let's set up our table of values. Again, we're going to have to do 2 of them. We're going to put our regular x values and our regular y values in our first table. Now I'm going to leave some space because there's an x transformation. All right, so we're going to do -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. So all I'm doing is squaring all those numbers to get the regular y values. So now we're going to do the x transformation in red. It's a -2, which means I'm going to add 2 to each one of these points. Okay, that's from this one. Our y value transformation is a ×3. And we've already talked about this in a previous lesson, so we're going to do the exact same thing as what we did before. We're going to multiply all of these by 3. Okay, so that's our y transformation. That's what happens to all of those numbers. And now I'm just going to write out my new x and y values. So my x values are going to be -2 plus 2, which is 0, -1 plus 2, which is 1, 0 plus 2, which is 2, 1 plus 2, which is 3, 2 plus 2, which is 4. Again, my vertex being this one here. And then for my y values, it's going to be 4 times 3, which is 12, 1 times 3, which is 3, 0 times 3, which is still 0, 1 times 3, which is 3, 4 times 3, which is 12. So what's interesting here is you can still see that symmetrical pattern to our parabola, right? But everything has been shifted over to the right by 2. And I'm going to leave you to visualize what that graph would look like. What would the graph look like if it was moved to the right by 2? It's positive, so it hasn't flipped upside down. The y value, the a value is positive, okay? And it is stretched. So what would that look like? And that's where we're going to finish the lesson for today. So there will be some homework. Please take a look at that homework, and we will talk to you soon.